So, what would happen if you had two people who were out in space, two astronauts, and they got abandoned by their spacecraft, and they're, a few meters apart, and they decide that they're going to wait until their mutual gravity pulls them together in order to, each one has something that the other needs in order to survive, or, one has a jetpack, the other has the fuel, and so they have to get them, together. They could possibly throw it, but then if they throw it, then they're going to have a kickback, and that might be worse for them, and so on. So they're going to wait until they are together. But the only force that they can use to do that, other than throwing objects off of themselves, is gravity. So imagine they're out there in space, and they're going to wait until gravity pulls them together. Okay? My initial intuition for this is that is going to be a ridiculous amount of time, and I'm thinking weeks to years, possibly longer. Gravity is so weak, and when we're talking about the masses of two people, maybe total of 200 kilograms between them, is not going to be much. So but one's intuition can be really wrong, so it's important to walk through the calculation. Now, in detail, this may be actually a difficult calculation to do because the force of gravity depends on distance. And so because of that, as they move towards each other, gravity gets a little stronger. We have to worry about kind of a changing force, and so calculus is needed for this. But we can make an approximation. So this is how I'm going to approach this problem and then see whether it matches my intuition. So I'm going to have the people start, say, about 3 meters apart. So they're going to start about 3 meters apart, and then they're going to reach the close distance of about half a meter. And when they do that, they're going to lose gravitational energy and gain kinetic energy. And I'm going to make the assumption that their final speed is achieved through kind of a linear increase, which we know it's not. But that'll at least give me the easy to do calculation. So we start with the masses of the two objects. We're going to start, M1 and M2. We're going to say that they are 100 kilograms. They start off at 3 meters apart. They end at about half a meter apart. And we look at the change in the total energy. We have the gravitational energy before, and then afterward we have some gravitational energy, a little less, and then we added the kinetic energy. And from that, we can solve for the speed that the objects will achieve. And then we can then say, okay, given that speed and a constant acceleration, how long will it take to collide from the beginning? Or we can say that speed is essentially twice the average speed across the entire approach, and then we can just use the speed as distance over time. And when you do this, you get around 12 hours, which is way shorter than I thought. So what I'm going to do is also pull this problem into a program that will be able to solve the changing force problem, a program called Pindamics, which is a wrapper around the Python package, part of the SciPy package in Python called ODE-int, which solves ordinary differential equations. So, but essentially it's for solving cases where the force changes over time. And when doing this, we find that the time is, a little bit more than the 12 hours I approximated, but not much more. And so our approximation is at least, reasonably close, and which is good, but it also shows that my initial intuition was terrible, that gravity is at least strong enough to bring these two together in a reasonable time. They're not going to wait long enough to starve to death. At least that they will actually survive. I like seeing cases where my intuition is incorrect, but that I was able to correct that intuition with a fairly straightforward approach.